All right, fifth graders, today we are going to be viewing Unit 4, Lesson 3, Partial Products in Algorithms. Let's find some partial products. We're going to do a warm-up today. Which one doesn't belong? Which one doesn't belong? We have some colorful rectangles. We have some not so colorful rectangles. And then we have, let's see, this is not even a rectangle. That's an expression, right? So I can go ahead and say that B is an expression, not a rectangle. So that's why it doesn't belong. It's the only one that is not a rectangle. Okay, let's see what else I notice. Well, I noticed that in A, I have a question mark here. In all the other rectangles, everything, all the products are filled in. So A has it's not finished. Not finished, right? For C, C is the only one that only has 3 partitions. Everybody else has 4. Well, these two have 4, right? And I see that they didn't break up the 40 and the 2. So this is what it would look like if they had, right? So that would be 160, and that would be 8. So C doesn't belong because it's the only one with 3 partitions or 3 groups, not 4. Okay, and then D doesn't belong. Let's see why D doesn't belong. I'm getting a different product here, aren't I? There's a 5 here where all the other ones are multiplying by 4. So this is 5 times 5,342. Very good. This one is 4 times 5,342. And this one is 4 times 5,342. And this is 4 times 5,342, right? They just kind of expanded it. They wrote it in expanded form. We're multiplying 4 times each place value. Awesome. All right, let's see if they have some questions for us to answer. Why does B not belong? Well, we already said it's an expression, not a rectangle. Does the value, let me erase some of this so we can see what it says. Does the value of B, expression B, match the value represented in any of the other diagrams? So does this value, oops, I'm erasing again. Sorry about that. Let me rewrite that. Remember, we said that was 4 times 5,342. They want to know if this is going to be the same as any of the other ones. Well, we already wrote that, right? It's going to be the same as this one, and it's going to be the same as this one because we're multiplying 4 times the same number, the same factor. Awesome. Okay, let's clean this up and move on to our first activity. All right, what product does this rectangle represent? Well, I can see this side, oops, let's go back a bit. Sorry, let's go back one. There we go. Let me get my stuff together. All right, so I know that when I have a box like this and I'm doing arrays or diagrams, I'm going to multiply this length times this length, yes? Or length times width, however you want to say it. So this is all added together, and this is added together. So for me, this would be 245 times 35. And I could use this diagram to help me to solve that problem. All right, let's see what they have us to do next. All right, let me take this out. So we have 3 diagrams at the top. They all say 35 times 245. Sorry about that. I keep clicking and I shouldn't. There we go. They all say 245 times 35. It says take turns picking out a set of expressions that are equal to 245 times 35. Use the diagrams if they're helpful. Explain how you know the sum of your expressions is equal to 245 times 35. And then what is the value? All right, so your teacher is going to hand you a set of cards, and you're going to have to tell me where they go. So let's go ahead and get to our overhead so we can see. Here I have that diagram, and I have a bunch of cards. And I'm going to see where they fit on the diagram. Okay, so I'm just going to go through. Here's 200 times 35. Well, it doesn't really fit on this diagram unless we put the 35 together, right? So I guess I could put it in the middle here. Whoops. But if I were going to draw this one, it would look more like this. 35 on this side, 200 plus 40 plus 5, right? Like that. And then the 200 times 35 would go here. But I'm not going to keep drawing for each one, so I think that we're just going to put that one in between because I can say 35 times 200. All right, this one says 40 times 35, so I'm going to put that one, same thing. If this were added together, it would be 40 times 35. Okay. Then I have one over here that says 5 times 40. Well, I can see that 5 times 40. I'm going to move these away because I'm going to use that in a minute. 5 times 40 would go here, right? 5 times 40. What about this one? 200 times, oh, that's the same. Let's see. 5 times 200. Where would that go? Well, here's a 5, and there's my 200. So I think that's going to go right here in my array. Okay? Here's another, but it's written differently, isn't it? But I know because of the commutative property of multiplication, that this is the same as that. So I can put that right there. And then the same thing goes for this one, doesn't it? 40 times 5. All right, here I have a 30 times 200. Well, here's my 30, and there's my 200, so that's going to go right there. There's another 40 times 5. All right, here's a 40 times 30. That one would go here. Here's another 200 times 30, 200 times 30. 5 times 30. Where would that go? 5 times 30. I don't have a 30 here. Oh, here we go. 5 times 30. There we go. 5 times 5 goes there, right? 5 times 5. 30 times 5. 30 times 5. Okay. All right. I think that might be it for this diagram. I might have to draw a different diagram. Oh, here's another 40 times 30. I already have that one up there. Here's a 30 times 40. Okay, the rest of these, I think I have to draw a different diagram to show what I'm thinking, right? So we're gonna wait on these. But these are good ones to be able to show the products so that I can add and find the product, right? That was what we have to do. So let's start with 200 times 30. I know 2 times 3 is 6. And I have 100, 10, 100, 1,000. And then here I have 2 times 5 is 10, 10, and 100. So 1,000. Here I have 3 times 4 is 12 with 2 zeros. That's 1,200. So that's 10 times 3 times 4 and 10 times 10, right? 4 times 5 is 20. And I have to multiply that times 10. 5 times 5, that's easy. 25. 3 times 5 is 15. Times 10 is 150. Now all I have to do is add all of these numbers up, right? 6,000 plus 1,000 plus 1,200 plus 200 plus 150 plus 25. All right, so for me to do that, I really like to write it out so that they're stacked up and I know what place value goes with what place value. So that's what I'm going to do on this page. 6,000 plus 1,000 plus 1200 plus 200 plus 150 plus 25. All right. Those are all zeros, and all I have is a 5. Those are all zeros. 5 plus 2 is 7. 0, 0. 2 plus 2 is 4 plus 1 is 5. 6 plus 1 is 7 plus 1 is, 8. 8,575. All right, so they did give me some other cards. So let me erase this really quickly. I'm going to put all these cards aside because I have used them for this array. But then they gave me some problems, some other equations. So I'm still doing 245 times 35. In this one, they gave me an array like this. Crooked there. So when I draw this one, I can see that they did not take apart the 245, but they still took apart the 30 and the 5. So I would have to do 30 times 245 and 5 times 245. That one is not fun for me, but for this one, what they did was they said 205 plus, what's that, 40. So I still have a sum of 245, and then they multiplied that times 30. Okay, that's one way you could think about it. For this one, they said, nope, we're not going to do that. We're going to do 240, and then we're going to have our 5 over here. And so this one would go right here, wouldn't it? And they have lots of other ones just like that where they took different numbers apart. So for me, I think it was just how you would have seen the problem. I like the way we did it the first time. But you can play with those cards in class. Ask your teacher for some time so that you can go through each different scenario. All right, let's get back to our slideshow and see what else they have for us today. So we did find the value, and the value was, remember, we did 6,000. Let me get a pencil. There we go. 6,000, 10,000, right? 10, 1,000. 3 times 4 is 1,200. We did 5 times 4 was 200. 5 times 5 was 25. And 30 times 5 was 150. And when we added all those partial products up, we got 8,575. Okay. So I hope that you and your partner did your work in a similar fashion. You might have had different results. Okay, let's move on. How did you find the value of 245 times 35? Well, I went ahead and I broke it up into partial products, right? And I found the partial product of each set of numbers. How do you know this equation is true? Well, I can put the 30 and the 5 together since they're both multiplied by 35, right? 35. So I can put the 30 and the 5 together. Oops, missed the line. Here we go. Back over here. 30 and the 5 together to get my 35. So that I can see that 245 times 30 is the top part of the diagram, and 245 times 5 is the bottom. Together, that's the whole diagram. All right. All right, here we go. We're going to look at 2 ways students recorded partial products for multiplying 245 by 35. You can see Andre and Claire. How are Andre and Claire's strategy? Well, how does this relate to what you just did? Well, again, remember those partial products that we got? Look at Andre's. That looks exactly like what we did when we did our partial products. We got 6,000, we got 1,200, we got 1,000, we got 150, we got 200, and we got 25, and we ended up with 8,575, right? So we got those same partial products. All right. How are Andre and Claire's strategy the same and how are they different? So I think they both find, let's see, how are they the same? They both find 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They both found 6 partial products and then added them together. And the partial products are the same, aren't they? 6,000, 1,200, 150, 1,225. Wow. So, how are they different? They found them in the exact opposite order, didn't they? Andre found 25 last, Claire found it first. Andre found 200 second to last, and Claire found it second. All right. Create a list of equations to match the partial products. Oh, awesome. So let's talk about how did Andre find 6,000? Do you remember how he did that? How did he find 6,000? Well, he did 30 times what? 200. For 1,200, Andre found 30 times 40. Do you remember that from when we did it? And then he found 30 times 5. Then he's done with all the 30s, right? He did 30 times 200, 30 times 40, 30 times 5. Now he's going to do 5 times 200, which is 1,000. So 5 times 200. And then he did 5 times 40 and 5 times 5. All right. Claire did just the opposite, right? She started with the little numbers. 5 times 5, 5 times 40, 5 times 200. And then she did 30 times 5. Remember, this is a 30. 30 times 5. And then 30 times 40. And then 30 times 200. So she's taking the place value of each one, right? 30, 30, and 40, 30, and 200. All right, let's see what they want us to do next. Both of these strategies use an algorithm that lists partial products. An algorithm is a set of steps that works every time as long as the steps are carried out correctly. How are both approaches the same? Well, they both multiply ones and tens by hundreds, tens, and ones. How are they different? One starts with the hundreds and the other starts with the ones, right? One goes from left to right and the other one goes from right to left. Why is it important to list the products in an organized way? That way I know that if I found all the partial products, I didn't leave some of them out or do some of them twice. So it's very important to make sure that I list everything. Okay. How does each expression relate to the product? All right. Today we found products of 2-digit and 3-digit numbers using partial products. We saw how diagrams can help us make sure that we found all the partial products. We also saw we could list products using an algorithm. How do you know that all the different ways to find the product give the same answer? How do you know that? Well, you're always adding up the same partial products. You're just calculating them and putting them together in a different way. And what is helpful to remember when you're using partial products to determine a full product? You have to make sure to find all of the partial products. You have to make sure to add them. And sometimes I can add them mentally and then don't need to list all of them. But for 245 times 35, listing them all in whatever order you want to go in. So if I used Claire's way, 5 times 5, 5 times 40, 5 times 200. If I list them in order, right, here, here, and here, I'm not going to forget any. And then I'm going to do 30 times 5, 30 times 40, and 30 times 200, which was 6,000. So making sure to list all of those in an organized way is going to help me to keep my answers correct. All right, let's get to the cool down. So we can do this in a couple of ways. We can use our box, our diagram, or we can use the algorithm. So let's do both. So I'm going to start with the diagram. So I'm going to break everything up this way. So here's 40 and here's 3. Here's my 43, right? And then I'm going to break this up into 400, 10, and 5. Now, if I were doing the algorithm, I would put 415 times 43. And again, you have a choice. Which way do you want to list those partial products? I'm going to list it going the Claire's way. 3 times 5 is 15. 3 times 10 is 30. 3 times 400 is 1,200. And I'm done with the 3. Now I have to remember that this is 40 times 5. 4 times 5 is 20, but 40 times 5 is 200. Okay, so I did this one. 4 times 10 is 40. And 4 times 400, remember that one, 4 times 400, well, 4 times 4 is 16, and so I'm going to add the 100. So let's see if I get these partial products over here. 4 times 4 is 16. Oh, it's 40 times 4, isn't it? So it's 16,000, right? 1, 2, 3. Yes. And then 3 times 400 would be 1,200. So I got that one right. All right. It's a good thing I'm doing this twice. 40 times 10 is going to be 400, right? 4 times 10 is going to be 400. I did that one wrong too. 40 times 10. So that's 400. 40 tens. And then 3 times 10 is 30. Good thing I did that one right. 4 times 5 is 20, but I have a 40, so I have to add a 2. Yep, I got that one. And then 3 times 5 is 15. Whew, I'm sure glad that I reworked that. All right, so let's now add up all the partial products. I'm going to write it over here to be neater because I like my numbers in order. So let's make sure I did that right. 4 times 4 is 16, but I have to add 3 zeros. Yes, 1, 2, 3. And then I'll put, oops, not right there. Let's undo that. 1,200. Yep, got that. 400. 200, 30, and 15. Notice I didn't write them in the same order. I just wanted to make sure it was nice and neat. So I have a 5 there, 0, 0, 0, 0, 3, 1, that's a 4, 0, 2 plus 4 is 6, plus 2 is 8, 7, and a 1. So 17,845. Whew. I sure am glad that I checked my work. Could you use either method in order to do this algorithm? Yes, you could do either one, but make sure that you're not like me and making silly mistakes. All right, I'll see you again for lesson 4.